Good morning, everybody. My name is Paul Andrew. Oh, that's a good start. Please don't do that. We are here to talk about building an Azure Data Analytics platform end-to-end. Sound good? Do we want to do that this morning? Yeah, okay, good. We'll get the energy levels going, shall we? Have we had enough coffee? No, more coffee required. A big thank you to the sponsors of this event. I run my own events over in the UK, and without sponsors, the events are not possible. So thank you to our sponsors. Please do go and talk to them during the breaks, find out what they do. They obviously want to talk to you. So, as I've said, my name is Paul Andrew. I'm a consultant over in the UK. I'm a data platform MVP, have been for 7 years. I've probably been designing and delivering data platform solutions now for customers probably for 15 or 20 years. You know, when you reach a certain age, you try to stop counting, right? So, but a long time, basically. I can date myself by technology, like most of us can. I started my career working with SQL Server 2000. Did anybody use Did anybody use SQL 2000? Version 7? Ooh, no version 7. One gentleman. 6.5? Maybe? I try and work out if I'm the oldest person in the room or not. I hope not. I also tell my children that I am older than Google, which gets an interesting response. I tell them that I know what a dial-up modem sounds like. They have no idea what I'm talking about, of course. Anyway, aside from all the things that I now do in the company that I run over in the UK, CloudFormations, I basically get to come and talk to you guys and share knowledge with the community. And for me, this is the very best part of my job. I love spending half of my week helping customers, half of my week sharing that knowledge, mentoring, training, whatever. So it's great to be with you here today. And feel free to reach out to me on the social media things at the top there. So yes, today, building an Azure Data Analytics solution, end-to-end, or at least a few stories of building it end-to-end, as you'll see. Now, just to caveat this, we will not really be talking about Microsoft Fabric. Who's heard of Microsoft Fabric? There's lots of sessions on Microsoft Fabric, of course. This will not really be one of them. Now, the main reason for that is because when I created this talk, I did so in about January of 2021. So my talk predates Fabric, and building this analytics solution in Azure predates Fabric. And if we think about that in terms of a timeline, as I've said to you, my career started with SQL Server 2000, and then, of course, everything got a lot more cloudy, a lot more Azure blue in February 2010 onwards. So I created my talk kind of on this timeline around 2021. And I was delivering data platform solutions for customers using all of these technologies, working in Azure ever since it existed. So we're not going to talk about Fabric lots, because I think ultimately as well, there's plenty of talks about Microsoft Fabric, of course, that you can go to. Microsoft Fabric on this timeline is still quite immature. It's still new. There is still some features that are missing from Fabric. Obviously, more announcements will come at Microsoft Build and other conferences, and time will move on, and Microsoft Fabric will certainly have those features in it eventually. But what I say to my customers is that if we think about a chart, and on that x-axis we have that product maturity, on that y-axis I think about delivery friction. Delivery friction when I'm deploying and building these solutions for my customers. Azure is very mature, certainly on this timeline anyway. Microsoft Fabric not so much, so we end up with delivery friction. And because of that, in this context, we're not going to talk about Fabric a great deal. So, with that out of the way then, the agenda for you today, fairly simple. We're going to design something, or we're going to look at designing something. We're going to look at extracting something. We're going to go through some stories and requirements I've experienced from customers. We'll think about transforming that data, loading that data. ETL. Do we like ETL? Do we need to rearrange those letters in some other way? Let's see. So let's start with designing something, or at least how I'm going to approach this for you. And let's start with a simple question that I'm sure this audience knows the answer to. What is the answer to life, the universe, and everything? Do we know this answer? 42, right? We know that answer, but I'm going to say no. That is the wrong answer. I want to change history, okay? This is not the answer. I find a far better answer, as I'm a consultant, is it depends, okay? If you take nothing else away from my session today, this is the answer to life, the universe, and everything, as I will demonstrate. Next question, what is big data? It depends, right? Sure. I like this answer, though. This is an answer that I heard from Mr. Bookwoody at Microsoft. Do we follow Mr. Bookwoody on Twitter? You should do. Please do so. Good guy. So Book said, any data that you cannot process in the time that you have or want, using the technology you have. I thought this was a good answer to that question. Ultimately, we could say that big data, it's relative. Maybe 1,000 rows of data is big if you only have a calculator to process it. So it's relative. And of course, over time, we've come to define that big data using a series of words that all start with the letter V. When I started working with big data, we had 3 Vs. Then we added the veracity and the value. I did a session with James Serra on Monday, and we had 6 Vs now. We had a variability in there as well. I feel like we're kind of just stretching a little bit now. Somebody also said there's now 8 Vs, and I was like, I don't know what the others are. But we will go with these 5 Vs for now. Next question then, what is the goal? What is the goal of any data platform solution? And I think simply we could say we have some data sources on the left. We want to get to the data insights on the right. That is the goal. The problem here has not changed. This is always the problem. The technology, of course, changes and improves and gets better, but this problem has not changed. And as we know, data becomes information, information becomes knowledge, knowledge is power, and we want power, yes? Yes, Paul. How do we get there then? We need to build something, don't we? As data people, we need to build the thing in the middle. Now, this is not magic. The customers I speak to, the stakeholders, the managers, they think it's magic, and that's great, but we know it's not magic. We know that that thing in the middle, we might call it a data warehouse. Would we call it a data warehouse? Do we like a data warehouse? We really need to get you guys woken up. I think we might have to put all the lights on really bright. And of course, as we know, we want to get the data from the source. Through that warehouse, we want to get the insight from it. And as we know, when we do that, we cleanse that data, we enrich that data, we conform it, etc., etc. All of these things that we might have to do. And as the technology has evolved, we might, of course, call it a data warehouse. We might call it a lake house. The problem hasn't changed, the technology is just evolving. So we can simplify, and we can call this Paul's reference architecture. What do you think? Impressive, right? Good enough, yeah. This is your design specification. I printed this off. I showed it to my mum. She was very proud. She put it on the fridge. It was a good day. Of course not. So this is my reference architecture. Microsoft might give you another picture. Shall we have a look at Microsoft's picture? Check this out. The Microsoft Intelligent Data Platform. How pretty is that? That's much prettier than mine, isn't it? Now, for those people that use PowerPoint, this is not a GIF, this is not a video, these are all single animations in PowerPoint, all custom paths of dots moving around the screen. Impressive, eh? Impressive. Anyway, that's what Microsoft might tell us, but I live in the real world, so mine is ugly and boring. But hey, it's simpler. So let's think about that, my first reference architecture, and let's move on. I'm just kind of setting the context here. The next thing I might say to my customers then, in that kind of design space, I say to them, well, what is your primary design focus? And I might show them a Venn diagram a little bit like this. And of course, what we could assume from this is that where all of those circles overlap, there is a perfect solution. We have to whisper about it, though, because if we don't whisper, I don't think it really exists. I think I might have seen it once, but I'm not really sure. Who knows what perfect looks like? Ultimately, because we do live in the real world, what I say to my customers is that we cannot deliver all of these things. We need to pick 3 of them, probably. Maybe resilience, cost is generally a priority for them. Scalability, I think almost certainly, otherwise they probably wouldn't be using the cloud in the first place. Performance, rapid delivery, reusability, sure. Ultimately, we end up with kind of human cost and human engineering, and is that the same as the total cost of ownership, the run costs? But this is what I say to my customers. We need to figure out what we're actually going to go after. Now, those customers that say, hey, we don't care about cost, that obviously makes the rest of this much easier if they don't care about cost, because we can spend lots of time building it. It can go really, really fast. We can use all the compute. But this is what we need to think about as that design focus to begin with. So we'll park that, and very crudely, I appreciate, I'll say, we've thought about the design. This is as much design thinking as we're going to do for now. Let's move on to extracting that data then. And what we're going to do here is we're going to look at a series of requirements. These are based on real stories from customers that I've worked with, one particular customer. And when we think about extracting that data, we might want to understand the data sources, the data structure. We might want to know if we're pushing, that data is being pushed to us in more of a real-time scenario, or we're fetching it. We need to know if it's batch or speed data. We need to understand the private networking. We need to understand the sensitivity. We need to understand the volume of that data. So I'm laying out some requirements here of that platform that we're going to build end-to-end together. And we'll start with specification number 1, our first set of requirements, if you like. I have some CSV files. I need to bring them in. I need to fetch them. It's a batch process. It's probably going to run daily, weekly, something like that. We need to go and get it from an on-premises location. We're not too worried about the sensitivity. The data is not yet considered big. We have enough compute to deal with it. So we take that and we start building our architecture. And of course, we have our on-premises network or our remote network, a hosted network. I don't mind where this exists. And we have Azure. And we have some CSV files that I want to get into my data lake. And I might use Data Factory. So I might deploy a self-hosted integration runtime to do that. I might create a pipeline. And in that scenario, I can copy that data. I can get those CSV files from on-premises up into Azure. I might need to put things like a Java runtime environment on here if I want to land those files as Parquet in my data lake. But we can do that. Given those requirements on the right-hand side, to extract that data, I might build an architecture like this. But guess what? The specification changes. My customer says, oh, I just realized I've actually got a lot more data to deal with. And we think, fine, That's okay. We can handle that. We've got more data that we need to ingest. We can scale out those integration runtimes. We can have up to 4 nodes to one of these endpoints. Those nodes will load balance. They will fail over. They can help us get there. So we can use those additional nodes with some copy activities, maybe with some for each activities that will naturally scale out as well, and we can bring that data in. So this is solution number 2, dealing with that specification. This is what we could build to extract the data. But guess what? The customer changes the requirements. Of course, that's what customers do, right? The customer now says, I'm actually going to start using private networking. I don't want to use public endpoints anymore. I want that extra layer of security, which is fine. This is good. We do want to do that. So in that scenario, we look at our architecture and think, I need to make some changes here. Now, the changes that we need to make if we are using an express route and we're using private networking is those integration runtimes that we've got deployed, we actually need to move them to the other side of that Azure boundary. It doesn't feel right to do so, but the assumption then being is that the networking people have then done something clever with the virtual networks, the Azure TIE Fighters, as I like to think of them, because I'm a Star Wars fan. So they've got their express route, they've got virtual networks, everything can now talk to each other with IP addresses and DNS, and who likes DNS? Good answer. Anybody that put the hand up would be invited to leave. In that scenario then, we can use those private endpoints. We can copy that data in, assuming these virtual machines now, they have access to maybe the file servers where these CSV files exist. Solution number 3, good. Requirements addressed. Guess what happens then? The customer changes their mind. Or we get another customer, maybe. I'm not going to blame the same customer for all of these things. But we need to then think about that evolution of our architecture. What else do we need to do to extract it? The customer now says, hey, I've got some other data sources that I want to bring in. That's okay. That's quite an easy one to tackle, actually, because these hosted integration runtimes, they support a lot of different data sources. They support ODBC driver connections if you need them. So maybe we've got SQL Server on premises as well. Maybe we've got something a little more exotic, like an inter-systems cache database. Has anybody had to deal with an inter-systems cache database? Don't do it. They're horrible. You have to use ODBC drivers that are poorly coded. Select star does not work. You have to know exactly what the attributes are within the table to query it, but you can't do that because you don't know what they are because you need to query it. But hey, customers, right? Solution number 4, achieved. We can do this. This is our architecture to extract that data in that scenario based on those requirements, potentially. Guess what happens? I've only got 2 more of these, I promise. The requirements change. Excuse me. The requirements change, and the customer now says, hey, I've got some sensors and some real-time data that I need to now ingest as well. Can you sort this out for me? Can you add this to the architecture? I was like, yeah, sure, I can do that. We think about our current architecture, we think about the devices that the customer now has, and we say, yeah, okay, I'm going to deploy an IoT hub, maybe, or an Azure Event Hub, as you prefer. In an IoT hub, we have 2-way messaging, we have device-level security. In an Event Hub, we don't have 2-way messaging, we have more scalability, so there's considerations there. It depends, of course, there's always the answer. But we can do that. We can bring that JSON in, those JSON messages from those devices maybe. I might use something like Azure Stream Analytics, and I might land that data in the data lake as well. So I'm bringing in the hot data with the cold data, the batch data with the speed data, however you want to label it. and we can deliver an architecture that looks like that. But of course, the requirements change. For the last time, though, I promise. The requirements change and the customer now says, hey, I've got some sensitive data I need to deal with. GDPR is a thing, right? The Americans don't know that GDPR is a thing, but we know GDPR is a thing. So they said, hey, I've got some personally identifiable information in here. Can you help me out? Can you update the architecture? And in that scenario, yes, we can. We have redacted data. Look, in my CSV files, look, here's that sensitive data. It's brilliant. Let's just draw more pictures. I tell my family my job is drawing pictures and colouring in. They believe me, which is great. They don't ask me for technical support, because all I do is draw pictures. Try it, it works. Anyway, in that scenario, what we might do when we extract our data, when we ingest our data, I like the pattern of deploying what I'll call a privacy store, what we might call a customer locker, or maybe customer 360, or something else, whatever we want to describe it as, but a privacy store where that sensitive data is going to go. And I will handle that ingestion of that sensitive data. Maybe we'll use some metadata to control our pipelines. We will divert that sensitive data into the privacy store at the point of ingestion, and then we might tokenize, anonymize, encrypt, whatever you want to do with that PII. And then once we've done that, it can then flow into the data lake as we intended it to. But now in a form whereby we can't identify the person in our data lake, because we want to do analytics. We can still do that analytics on those values, we just don't know who the person is, or whatever that sensitive data is, maybe credit card numbers or something else. But what it does mean is that in that privacy store, I could reverse engineer that PII if I absolutely needed it, maybe for some downstream data science use case where date of birth is important or whatever. You know, sure, we could still do that. But in this pattern as well, it means that if somebody wants to invoke their right to be forgotten, we can do that because we just remove them from the privacy store. The analytics world can still continue with those values that we just can't reverse engineer anymore. So we might end up with something like this. Maybe. It depends. There's obviously lots of things there that I've gone through, lots of different icons on the screen. But we could take that pattern and in our overall architecture we could say, yes, this is how I'm going to extract my data, how I'm going to build that end-to-end analytics solution. So part one, done. We've done a little bit of design, we've extracted some data. Let's move on to the transformation then. We still need to transform that data. We still need to do data modeling and all those other things. In that transformation area, we ultimately need to think about compute and storage and the structure and that format that we're going to use to handle our data. If we think about compute first, and just as a slight digression here, because I see people make this mistake and describe this wrong lots of times. We say that we have some work that we want to process, maybe some big data. And we deploy some compute. I'm being very generic and very simple here intentionally. And if we need to process that data quicker, we might scale up that compute. We make it bigger. What we also might need to do is scale out. Maybe scale out lots. And this is really just that distinction and the point I want to make. It's a simple point, but that difference between scaling up our solution and scaling out. Maybe we want to do a little bit of scaling out. We don't do any scaling up. Maybe we need to parallel process things more. Of course, in the real world, we try and find that sweet spot between scaling out and scaling up, only using the compute that we want. Performance tuning, query tuning is still a thing. We don't just deploy more compute because that's more cost. Go and improve the queries. Microsoft would love you just to buy more compute to make it faster without tuning your queries, but that's because they get paid for it. Scaling up versus scaling out, fine, done, we understand. Then we need to think about, well, what type of compute? And when I say what type, I mean something as a service, right? We must have heard these things lots of times. Platform as a service, infrastructure as a service. Microsoft are now trying to convince us that Fabric is software as a service. Who thinks Fabric is software as a service? Who thinks it's platform as a service? Who thinks it depends? Interesting. Interesting. We will see, won't we? But we're not talking about Fabric. We're talking about the mature technologies. So we're going to look at platform as a service technology. We care about the data, the application. We don't really care about the other stuff that comes underneath it. So in that scenario then, if we look at Azure, we look at all of the products in Azure that we could use to transform our data. And there are a lot of them. There are also intentionally some wrong answers up here as well. But I've seen customers use the wrong tools. I've seen customers build data warehouses in Cosmos. That was a bad day. I've seen people using Data Lake Analytics, which has now been retired, of course, by Microsoft. Does anyone use Data Lake Analytics and use SQL? A little bit, yeah. Using C# and T-SQL together in this distributed way. Great tool. I loved it. Anyway, it's been retired now. But of course, what we'll probably say is that we have our favorites, don't we? The favorites here is Synapse, maybe, and Databricks. Again, considering that timeline and that evolution. If we want mature technologies, less delivery friction, these are probably the two that we're going to go after. And my customers did and have said to me, which is better, Synapse or Databricks? The answer is it depends. But we know what it depends on, and cost, cluster management, and different things like that, but we're not going to get into that today. Ultimately, I feel like Morpheus from the Matrix. Do we take the red pill or the blue pill? And just as another aside here as well, because you probably get my crazy sense of humor by now, Keanu Reeves. Keanu Reeves, I believe, is secretly a data engineer. I don't know which pill he took. Maybe he took both. But thinking about Keanu Reeves and thinking about what I'm describing to you, guess what else Keanu Reeves did? The Lake House. He is secretly a data engineer. Second B-side point here. It depends on Keanu Reeves as a data engineer. Okay, good. Moving on. We've picked some compute. We've taken the red pill. I like the red pill. Do we like Databricks? Yeah, of course we do. Storage. Storage is easier. Storage, we have one option. An Azure storage account. I like that. Using the distributed file system, of course, underneath. And now, as I'm sure we know, we enable hierarchical namespaces in that storage account, which gives us those data lake capabilities. What Microsoft now tell us is an Azure Data Lake Gen 2. Is anyone using a Data Lake Gen 1? Good, because that's also now gone end of life support as well. So don't use that. But yes, we've got one option. That's easy. I like just having one option. So let's build our data lake. Check it out. My first data lake. I printed this off, showed it to my mum. She put it on the fridge alongside my reference architecture. Proud moment. What do we do with our data lake? We carve it up, don't we? We carve it up something a bit like this, and we have this crazy path of getting that data in. It's magic. Is that what we do? Do we end up with a data swamp or something else? I don't mind how we describe it or what we call it, but ultimately, yes, we want to carve up our data lake into something sensible. I like calling things by what they are, raw, clean, or cleansed. aligned, conformed maybe, prepared, enriched, all of those things that we called out in that data platform reference architecture earlier. Now, you might also like using metal, bronze, silver, and gold. We could also do that. I don't mind. But what I do mind is if we don't have consistency. We don't have definition for these things. Definition and consistency. A clear taxonomy of what is actually going to go into each of these buckets. We don't have to have all of them. I don't need 5 layers in my data lake, or 6, or however many you want. But, we could. It depends. So we bring things in. Maybe we partition it by, year, month, day. Probably quite common. Maybe we do something in the aligned layer to work with that data. Again, we don't have to. It doesn't matter. But as long as we have consistency. Consistency when we bring that data in its raw form. I like to bring it in its raw form in whatever state it was given to me. So I keep it the same. I don't want to deal with schemas and things at the point of bringing it into raw or the landing zone. I want to deal with that downstream. And of course, what we'll almost certainly now do as well is store and structure that data in the format using Delta Lake. Are we fans of Delta Lake? Yeah? Delta Lake giving us those ACID-resilient transactions now over our distributed storage. In a Delta Lake table entity, as I'm sure you know, we have the Parquet files to store the data. We have the JSON files storing the transaction log and all those other good things and that metadata that accompanies what we then need. So we can start defining things as table entities in our data lake to control, handle, support, and structure that data. So this is what we then might do to kind of organize and create that data warehouse. And we say, fine, I've thought about the compute, I've thought about the storage, I can bring that in to my architecture, in this kind of end-to-end view of creating something. And I say, yeah, I'm going to do it like this. I'm going to use Delta Lake. It's got Parquet in there. I might have some streaming data and things as well. I might use a landing zone. It depends. If I wanted to use an Azure Event Hub in here instead, it has a great capability called Capture, where you can write that data directly to your data lake. So, we could do. There's lots of different options, lots of different ways we could do it. But I'm going to say, yeah, I've done that. Here's my data lake. I'm going to maybe use Databricks to do that transformation work using Apache Spark underneath. Reading and writing those Delta Lake entities, all good. And then maybe I use another data factory to do some additional orchestration of that underneath. Fine. We've done the transformation part of our analytics solution. Let's move on to that loading part then. Loading that data. Where are we loading that data to? What do we need to do with it after we've transformed it? Have we got enough in our architecture already to deliver it? What's going to come at the end? It depends. But let's think about the things that we could do if we move everything over for a moment. I give you all motion sickness with PowerPoint animations. So we arrive at this prepared layer. The data is structured in a dimensional way. Maybe we have some facts and dimensions. We've got everything we need. It's cleansed. It's pretty. It's got what we want. It can help our business users. Sure. What do we do next? What we could do is create a serving layer. A serving layer maybe in SQL with a SQL endpoint, serverless or otherwise, using the Databricks SQL capabilities now, maybe using the Synapse SQL endpoint. Sure, we could do that. We might create a semantic layer. We might do this in Azure Analysis Services. It's very expensive, but we might do. It means then that the business users can self-serve on that data. They don't have to worry about joining tables together like they might do in the SQL endpoint. those tables are now joined and modeled for them. We might cache some of the fact tables, and we might have KPIs and things and contextual measures that help them in there. So we might want to do that in that modeling layer. We could do. And then, of course, beyond it, we then might want to visualize that data. Visualize it probably in Power BI. Do we like Power BI? Do we like Tableau? Click view? It depends, yeah, good. Does anyone like MicroStrategy? Okay, good. Good answer. So yeah, we could bring that data in. Ultimately, rather than worrying about applying all of the technology, we go down that path as technical people of solutionizing and say, yeah, let's do this, this, and this. I like to talk to the users, look at the personas of the people that I need to serve that data to. Maybe I'm working with the data science team, and they probably don't want a serving layer or a semantic layer. Maybe they just want access to the Delta Lake entities directly. Sure. I might have some analysts that want to explore via SQL, create some other kind of custom reports and things. Maybe I've got my business users that want to self-serve. Maybe I've got my senior stakeholders, the managers, the executives. You can tell they're executives, look, because they've got ties on. Look, they're very important. But ultimately, yeah, it depends. Now, another way to think about it as well, if we're thinking about the requirements here, is that we could say, well, in my data lake, I'm going to house 10 years of that data, or all of the data that I have. And then, of course, as I move forward in those layers, I might say, yeah, in my serving layer, I'm only going to have 5 years of data. Maybe in my semantic layer, because analysis services here is expensive, I only want 2 years, because I only care about that year-on-year reporting. Definite common patterns or scenarios. Excuse me. Again, as long as we understand what we're doing, as long as we have definitions and we've done that design well, what I'm saying is that we're not just fitting the tools to the problem, we're actually using the right tools for the requirements that we have. Now, we could drop the semantic layer. We could just serve that data directly to Power BI. We could drop the serving layer and just have the semantic model in there, of course. If we wanted to, we could do something really funky using our Synapse dedicated SQL pools and Polybase to load that analysis services model. It's a pattern I've used a long time ago, but it's a good pattern and it works if you've got a lot of data that you need to put in there. So you could do that. We could, of course, now consider exposing the Delta Lake entities directly to Power BI. We can do that via the Synapse serverless pools. We can do it via Databricks and the SQL endpoints there. We could also do it with the Spark connectors that we get in Power BI. If we just want to put maybe some Parquet outputs in here, maybe one big table of all the things in the data mart that we want to visualize. Yeah, we could do. Ultimately, as long as we're making the right choices there, we can figure out what we might want to do next. But if we turn that into some icons and we fit that into our picture, maybe we end up with something like this on the end of it. We have something like this that says, yeah, okay, I've created that solution. This is my end-to-end platform. Do we like this? Does this look like a logical architecture that we might build? It's a fairly horrible picture, right? Can we name all of the icons in this picture? Maybe. There's other things that we could do here, though. There's other things that we could do, maybe like taking a feed from Stream Analytics and sending that out to Power BI. We can create live dashboards in Power BI based on that real-time data. We want to keep that hot path going. We want to take it in there. If we consider building that, we also, of course, need to worry about DevOps. Do we like DevOps? CI/CD? Who has dedicated DevOps engineers to do it for them? You lucky people. We need to probably consider building out 4 environments here. Dev, test, maybe UAT, maybe pre-production, production. We've got to do all of that work as well, right? That's hard. We might want to do something as well, because we're thinking about ops here, the operational part. We might want to deploy something in our architecture like Azure Log Analytics. Log Analytics to take all of the telemetry and events from all of these resources, and I might want to create some operational dashboards in my Azure portal to actually support where that data is going to go, to help my managed services team troubleshoot things. We can write some KQL queries in that Log Analytics workspace to understand when pipelines fail, or average run times, or how many rows are actually processed through each of those layers. We might want to do that as well. We probably want to extend our orchestration to manage the compute, to manage the cost. We're in Azure. It's something that we should almost be designing for. I said in those design priorities earlier. If we're designing for cost, we want to scale up and scale down, scale out, scale in those expensive compute resources. I had a scenario with a customer using Azure Analysis Services. They wanted to keep that analysis services model within a cheaper SKU. So, they only had the year-on-year data. We can't just keep loading every new bit of data into it, because we have limits on the size if we're trying to keep it small. So we partitioned all the fact tables. We dynamically, at execution time, created the next partition, loaded the partition, then dynamically deleted the last partition off the end of it. So we kept that 2-year window of data. These are things that we now have to do in Azure, because we're designing for cost as well. We're not finished there. Did you know we have to deal with security? Who likes security? Good, no hands. We do the security though, right? We don't like it, but we do it. Not sure. We need probably Azure Key Vault. We might want to consider customer managed keys and encryption. We might want to consider building some custom security roles that kind of go in here. There is definite problems and holes with this. We could use managed identities in Azure Data Factory, and we say, yeah, I want Azure Data Factory to read all the keys that are in my Key Vault. Makes sense? Probably a common thing to do. In that scenario, I went to a customer's organization. I said, here to help you with your data platform. They said, oh yeah, we've got a SQL database that's acting as the warehouse at the time. This is fine. I said, oh, can I have the SA password to your SQL database? I was feeling a bit arrogant on that day. He said, no, of course not. The DBA said no. The DBA slammed the door in my face, which was fair. He said, I'm going to give you contributor access to Azure Data Factory only. I said, fine, I'll look at your pipelines. I then emailed him the SA password to his SQL database. He was not happy about that, as you probably expect. And he said, how did you do that? I said, well, Data Factory, using its managed identity, can access all the keys in Key Vault. You stored your SA password in Key Vault. You gave me contributor access to Data Factory. I built a pipeline, I queried the Azure Management API, authenticated using Data Factory's managed identity, listed all the secrets, listed all the values of those secrets, sent him an email. Once upon a time, we did Kerberos and we did double hop authentication. Now in here, we give everything access to everything using its managed identity, but my advice is that that's risky. We do need to do security better in Azure at that control plane. Those role-based access, those standard roles that Microsoft give us at that control plane need to be improved. I want a Data Factory reader role only, or a Data Factory pipeline run only, like we had in our SQL Server agent for the MSDB. We had a SQL agent executor or reader, or we had more granular control and security there. So I'm digressing slightly, but excuse me, please do security. It's important. And I'll give you one example of why. We almost certainly need to deal with VNets and private endpoints, right? I'm not a networking engineer, but I feel like I need to be, especially when I'm dealing with Databricks. I went to an enterprise customer. I said, hey, I'm deploying Databricks. Can I have some IP addresses reserved on your virtual networks, please? They said, sure, how many do you want? I said, well, each node within a Spark cluster will use 2 IP addresses, including the driver node. I said, well, I want the clusters to scale pretty big. We knew how much data we were processing, et cetera, et cetera. I said, oh, can I have like 16,000 IP addresses, please, reserved on your corporate network's address space? They said, no. They said, you can have 5. They had lots of peered networks, lots of TIE fighters. Darth Vader was in there as well. There was chaos. They had an express route. Fair enough. I said, 5? They said, yes. I said, well, the cluster's not going to scale then. You can have a driver node and a worker node, max. I said, your data is not going to process very fast. They said, well, you're the data engineer. That's your problem. It's like, no, this is a networking problem. I need more IP addresses for my cluster to process your data. No, that's a data problem. This was honestly the conversation I had. But yes, we need to consider it. We need to consider maybe our integration runtimes. We need to consider those regional things. And we start adding more and more icons to this picture. And it gets harder, right? But this was kind of the point here of building that analytics solution end to end, potentially. This is not a nice picture, but this is the picture that we could go with. Should we build it like this? It depends. I told you, it depends is the answer. It's not 42. So yes, maybe we build it like this. Maybe we do something like that. And then that is your end-to-end analytics solution that's been built in Azure, extracting all of that data and all those different things and getting there. So to kind of conclude in the last kind of 10 minutes that I've got here with you today, we think about that, and let's kind of just dissect it a little bit more, because it's a horrible picture. The first thing that I'll say to you is, having built all of this hands-on, you cannot be a good architect without being able to roll your sleeves up and do the doing as well, something that I definitely believe. But ultimately, the first thing that I would say to you is, we have a breadth versus depth problem here in terms of all of that knowledge that we now might need, that we might have. And the reason I say this to you is because, honestly, I feel it too. Technology is constantly evolving. There's more and more things. Every time I open the Azure portal, it feels like there's another 20 options that have appeared when I look at a particular resource. So, hopefully, as we're among friends, let's just be clear. Don't try and stretch yourself in both directions too much. I've worked in teams where I've had a dedicated DevOps engineer. It's been brilliant. I've had a dedicated security guy. I've had a dedicated networking guy. I've had a platform owner. I've had data domain owners, and I've had people doing analytics and visualizations, specialists in these areas that can actually go to that depth to achieve what we need to achieve. I've also been on projects where I've had nobody, and I've had to do it all myself. It's taken much longer, but, So what I'd say to you is that that picture is horrible, and there is a breadth and depth problem. That's okay. It's not what you know, it's who you know. And I think the great thing about our industry is that we are willing to share knowledge. We are willing to help each other. So go and ask for help. I do it every day. Let's come back to this picture, right? My reference architecture. Looks pretty nice now, doesn't it? I said it was ugly in the beginning, but compared to all those Azure icons, this looks pretty nice. This looks like a good design. The thing that I wanted to call out here is I said, do we want a data warehouse or do we want a lake house? Who wants a data warehouse? Who wants a lake house? We could do it depends. Who wants it depends? Yeah, sure. I think because technology has evolved, the thing that I would say is that, once upon a time we did this, or maybe we still do this. This is not wrong, this is not bad. We had our OLTP database, we had our OATP database, and we did ETL, extract, transform, and load. We got that data into a warehouse, we got that insight from it. Fine. I think all that's really happened, though, is because of that evolution. If we think warehouse or lakehouse, the way I would evolve the picture is simply like this. I now have Delta Lake, I now have Spark. Open standards now in the industry, which means that I can process that data at scale. I can scale out. We could make the argument that my data warehouse here, maybe running on a SQL Server database, could only scale up. Now, I appreciate with high availability groups and kind of other quirks and things, we can do some clever things, but generally, this is not a distributed computing engine as a database. Whereas, of course, with our distributed storage, our Hadoop file system, with Spark, running those Spark applications, we are distributing. We are more cloud native, if you like. So just kind of closing thoughts there on that. If we think about everything I said in terms of getting that data and serving that data, I want to get to that insight as quickly as possible. I don't want to go necessarily through all the layers and use all the icons that I showed you, but I definitely need to get to it. And we talked about a couple of patterns earlier. I said, yeah, we might do a SQL serving layer, we might do a semantic layer. We might use Synapse with a dedicated SQL pool, or using Apache Spark, or using the serverless SQL. Yeah, we could do. We could, of course, use Databricks in there. We could maybe consider using something like Delta sharing and having that Unity catalog to help us bring that data together in our visualizations. We, of course, may want to use Fabric. Happy to talk about Fabric at this point, because ultimately it's an evolution. And if we understand all of that pain and all of those things that we've been through in what I've deployed before, then now Fabric actually starts to make sense. Because suddenly all of that plumbing and virtual networking, some of the security and things as well, some of that pain, because Fabric is that unified platform, it starts to make a lot more sense. So we could use Fabric, and that's fine. The other thing to think about here is that on the left-hand side of my dotted line, we could also be cloud agnostic with everything that's there. We, of course, can run Databricks on AWS and GCP. A lot of industries now need to start thinking about being multi-cloud for regulatory reasons and good reasons. Amazon recently announced the fact that egress charges from their platform is now free. It is free from GCP as well. Microsoft, of course, you still pay for the egress charges if you want to take the data out. But in that context, the things and the problems that I face now is it's not just building that end-to-end solution. It's about customers that want to be multi-cloud. They don't want vendor lock-in. They don't want proprietary formats that they can't do things with. Not attacking anyone in particular, but they're out there. We want open standards. A term that I'll throw out there is one that I've heard a couple of times now, which we could consider as sky computing. All of the sky. We take all of the clouds, we don't care which cloud we use, Azure, GCP, Amazon, whatever, all the clouds, and we have a sky platform that sits across all of them. And we can only achieve that with open standards. So kind of just things to think about here as well, beyond what I've already talked about and told you. In this picture, who wants option one? There's no wrong answers, by the way. We're all among friends here. Who likes option two? Option three? Option four? 5? Do we like delta sharing? Option 6? What do we think about Fabric in option 6? Maybe? Who wants option 42? Yeah. The other kind of thing I'll leave you with as well is this picture. Another pattern. This is something that I've been playing around with and doing with some customers recently as well. Do we want to use the mature products in Azure to ingest that data, to bring it into our data lake? I like calling things, as I said, by what they do. Landing, raw, cleansed, maybe rejected, if there's some bad rows in there, curated, and that semantic layer. Maybe. Now, I won't call this a medallion architecture. Medallion architecture is not an architecture. It's just a set of definitions for bronze, silver, and gold. It's the one thing that Simon Whiteley and I actually agree on. It's not an architecture. So what I'll say is that I've got the layers of my solution. I will assign it a medallion status, a status of where I think it's at in terms of that curation. So this is what we could do as well. And I've done this for a couple of customers now where they want to play with Fabric, but they, of course, don't want to disrupt everything that they've already built in Azure. So in that scenario, we take what they've modeled, we mount that data lake in one lake, and then we use it in Fabric. So there's just another pattern that we could do. Again, it depends. Next, I'll just call out as well for you, if you want some further reading, I highly recommend James's book. Did anyone come to James and I's session on Monday? Thank you, friends. Hello. So go and grab a copy of James's book. I'm not here to sell it. I get no benefits from this, but it is a good book. James might still be around somewhere here today as well, so do go and check out his book on deciphering data architectures. He's got 40 years experience, and it is kind of to the point of what I've said to you today. We could build an end-to-end analytics solution a little bit like the one that I showed you. There's a timeline, there's an evolution here. So we can then think about it in terms of actual patterns and etc. as well. And with that, folks, I will say thank you very much for listening. Thank you for indulging my silly sense of humor and my general grumpiness and cynicism. Do feel free to connect with me on LinkedIn, and happy to drop me an email. You know, let's have a chat about some of the challenges and things that you're facing. I love kind of collecting those customer stories and experiences, ultimately so I can then share them with the next person. So thank you very much. Dziękuję.